Hello, NDC. Thank you, everybody, for being here on a Friday afternoon in the last presentation time slot of the entire conference. I appreciate it. Room full of people, that's very nice. We're here to talk about containers today. All right, I have a couple words about myself. I'm Oliver Sturm. People call me Ollie. I work for this company, DevExpress, where we make a lot of components and stuff like that. And we do use containers, but that's not related at all. So if you'd like to contact me at some point, find some details here. I never receive enough email, you see, so that's why I keep asking for it. So there it is. It's my own fault, really, isn't it? So this is what I have planned today, and we have a lot of stuff to walk through, basically. Well, I should say perhaps that the idea for this presentation was born when I realized that a lot of people have not really paid attention to containers for a long time, or maybe not enough, right? And now they find themselves in a situation where their teammates and their bosses and everybody else suddenly seems to think they know exactly how all that works, right? Like that. So it's a bit like when everybody suddenly thought you needed to know how to git cherry pick something or whatever, and you're like, well, I don't really, because I kind of wasn't thinking that was important. So the containers are a bit like that, I think. A lot of projects use them today. There's a lot of things you can do with them. And I'm hoping to pick all of you up somewhere where your current information status goes with regard to containers, and perhaps, give you a little more. So we'll see how that goes. Right, I'm going to just say a few more words. I've got like about 3 slides or so, I think, and the rest of everything I do will be live. I hope that works. I'm going to have some typing to do on here too, so that'll be fun, but we'll manage, right? So that's the idea. So live demo is the biggest part. You have by now read the slide, I'm sure, so nothing much more to say about that, really. So what are containers, or rather, where do they come from? Where do they live, as it says on the slide? Well, containers originate from this Unix-y idea of what was called a change root jail. Anyone ever work with that? Yeah, I'm old, right? I am. There are a couple of hands, or like half hands, not bad. Yeah, so the idea was that basically you would have an encapsulation of some sort of a server process. That was the idea on Unix, at least at the time, right? If you're running a web server and it was supposed to be blocked off from the rest of the system, so that if somebody hacks the web server, they don't suddenly get access to everything else on the machine, right? Simple idea. And that idea sort of went from being a simple command, it was literally called change root in Unix, right? CH root, like that, to this entire plan of kernel-supported container environments that would have all their own allocated resources and all that kind of stuff. Now, if you think that sounds a lot like a virtual machine, it does, but the virtual machine works differently because it has, as you can see on that slide right there, a hypervisor, right? Some sort of a central coordination process that sort of takes care of all this, whereas the mechanism that brings containers onto a system, an operating system basically, does not require anything other than the host operating system to be able to sort of encapsulate those processes. So if you run containers on a Linux machine, for example, you can see that the processes running inside the containers appear side by side with those processes running on the host operating system, right? They are not visibly separate from the other processes, which, may be a pro or a con. You need to know what you're doing, of course, right, to make that work properly. But it does, okay? And then Microsoft came along and said, hey, we would like to do that too, but on Windows, we will need to use virtual machines to make it happen. And that's how containers ended up being run inside virtual machine environments on top of a hypervisor, basically, right? Which is also part of the diagram there. That's why it looks so funny with this orange bit sort of stretching around that way, right? So that's the story today, really. Microsoft has made some changes again with WSL coming along, so they can now integrate that better with the Linux environment and so on. So that's all cool, but we don't need to go into that in great detail. I just wanted to leave you with an impression. Where do containers belong, and what do they do, right? Where do they live in your system? So you can run them locally, you can run them on some sort of a remote system that you access through SSH or something, right? That's not a problem. You are familiar with the idea of deploying to containers, perhaps, right? In the cloud somewhere, where there are basically management interfaces for those purposes, running on machines that you never see, right? So that's all containers, basically. Today, we will talk a lot about the developer side of all that, and not so much the deployment and IT side of the same technology. So let's see. Oh, here we are. Yes, okay. So sometimes people ask me, where's all the colorful stuff that I can click on? I think it said that on the other slide as well, because that's literally a question I get sometimes. I will use Docker tools in this presentation to make things happen, right? You might have heard that there's also a thing called Podman that is an alternative UI, basically. So it'll lead us a bit too far to explain exactly how that works, but basically the container technology these days is integrated in most operating systems. So if you use Podman or Docker, you're not really using different container technology. You're using different front ends, different management libraries, and so on, and different user interfaces, slightly different ones, because they are all extremely basic. The user interface of Podman is the one in the background on the slide there. I appreciate you can't see everything that's there. It's not super important. There are just a few edit fields that you can fill some values in and click OK, and the thing just goes and runs a command line in the background for you, right? More or less like that. And in Docker, that doesn't even go quite that far. You mainly use the UI only to see what sorts of resources you have in your system, which images do you have downloaded, and so on. But a lot of the time, in the end, you do that from the command line. I have this here as well as a sort of joke right there. That is your UI, I'm afraid. Or I'm not afraid, really, not myself, but some people are. And the command line, of course, stretches from anything from your local development system, which in my case here is a Mac, but it could be a Windows machine running PowerShell, if you like, or running WSL, anything you want, really. And of course, all the way to the deployment scenario I was talking about, where you might find yourself in an SSH session on some VPC in a cloud environment or something like that, right? So that's all the same thing, and that's why the command line is the primary user interface for everything that we'll do here today. Right, so let's see how things actually happen. Hang on just a sec. Bit of water. So the first thing that I ever started doing with a Docker container is that I ran one, basically, right? That was my first exposure to this entire thing. Oh, I should ask, is the font here large enough for everybody in the back? Yes? Yes? All right, good, good. So I basically decided that I was going to use containers as a resource for my development purposes. So a client comes to me and says, hey, I need to be able to use MongoDB or something with my application system. I don't have MongoDB. Running it as a container is super simple to do, right? Running something in general works like this. You go Docker run like that. And it's always a great idea for your future reference to put --rm in there, which means remove. And that's interesting. Start by removing stuff, right? No, that means after the run is over, it will go and remove any artifacts that it has created in the local system so that nothing ends up hanging around. If you don't do that, you end up having lots of locally created volumes and stuff like that in your system after a while. So generally good idea. And the first image that people normally end up running is called Hello World. It actually says so during the installation of Docker itself, that you can use it to test whether Docker actually works properly on your system, right? So that's how we run things. And I said Mongo, so let's do Mongo, right? I'm just going to remove Hello World and put Mongo instead. And Mongo is quite verbose. It comes up and shows me a lot of things that are happening on startup of the MongoDB database server. So that doesn't entirely matter, but that's how easy we can start that, basically. Now, the containers that I create, terminology, first of all. The thing we run is called a container. the thing that it is created from is called an image, okay? So images are like the static thing that don't do anything. They are the templates that are used to generate containers, and they are then executed. And in order to execute the container, they need to know, of course, how that works. What is the actual command or so that needs to be run in this container? So at this point, obviously, the Mongo container went and ran the MongoDB database server, but I can also override this and say, give me a bash shell instead. And then absolutely nothing happens. That was on purpose, because that's something that people frequently do, right? They read somewhere, you can just put a command at the end and so on, which is totally true. But you also need to make sure with another parameter here, -it, they're technically two parameters, right? -i and -t, typical Unix thing that you can just combine them. This makes sure that the terminal environment actually binds itself to like the standard in and standard out file descriptors and stuff like that, so that we can interact with the container once it runs, which of course is necessary for bash, right? So now I'm inside the container, which has the interesting name of 3A7 something or other, and I'm the root user, typical Unix type command prompt right there. We can do like PS and see that there are practically no processes running inside this container right now. So I have successfully overridden the standard startup behavior of this container. It was supposed to be Mongo, and now it's just bash, right? Nothing else. You can see from the outside what the startup behavior of a container is by inspecting it. So we can do docker inspect Mongo, and it outputs a lot of stuff here that we can see. There are things here like the command item that says MongoDB. There is also, here it is, the entry point. That is a separate part of the startup process. Basically, both are used. The entry point and the command are combined. And the shell script that you see here with the entry point in this particular container is coded so that if I pass anything other than sort of Mongo there, it automatically just goes and executes it, which is why I was able to override the command for this container, which is just this bit here, just by putting bash, right? And I didn't do anything to override the docker entry point.sh part. I left it as it is. But that's specific to the container, okay? So the best way to figure this out is to read the container documentation, which of course exists on the website wherever you find that thing. I mean, in the case of Microsoft containers, they have their own documentation on Microsoft websites. Typically, you can find images like Mongo here also in the Docker Hub, which is like a repository where these images come from and so on. So that varies. There is no secret trick to figuring it out necessarily, unless, of course, you're going to go in the container and read all the source code or something to find out what precisely it does, right? So in this case, the Mongo container is just coded that way that I can override it. I'll show you an example later with a .NET-based one where we have to override the entry point in order to do anything non-standard inside it. So we've managed to do this. Now let's see, what I'd really like to do just quickly is to do something useful inside this Mongo container as a quick example. So let's see, I'm going to run a Mongo again. Where are we? Like the normal one, here we go. Let's run this one. And now from a different terminal, I can do something like docker ps, and it tells me that this is now the running Docker container that I just started, right? It has a name, which is auto-generated over here. It's possible to assign your own one. It otherwise uses funny words to create one every time you run a container. It also has an ID, which I tend to use a lot more frequently than that. And this is the ID. That's actually just a short version. The real ID is like a lot longer. When you need to use the ID, we can actually refer to it by using any unique part of it, right? So in this case, F1 or something is going to do the trick. Now I can do docker exec and pass -it, okay, for the same reasons as before. And then I give the ID. So F1, this will use the existing container to execute another command in it. Let's go for bash one more time. And the difference now is that I can see the running Mongo process in there because I'm sort of getting into the container from the side, right? So I'm using the existing container to run my command. The reason we might want to do that is because with my running database server, I could bring up the Mongo shell here, like this, and do things with my database. db test insert one, curly event NDC location Oslo, like so, perhaps, insert an actual data object in the database, right? We can interact with that running process just like that. And I'll leave it again and do another one like Mongo export, not expert, minus D, that's test, minus C, collection is also test, and we'll do quiet. And I think for better formatting, I should now remove this, like so, and then maybe I pipe this into JQ and get a nicely formatted JSON output for like a backup or something you might imagine, right? From my running database server. So this is a very common thing that you use. And if you think about it from a developer's point of view, then of course you could also use this to prepare some kind of a database session, right? I can simply pipe information in and out of the container. I mean, I'm saying pipe because that's literally what I did right here. This is the pipe symbol that is sort of between the command that runs in the container and the other command that runs outside the container, right? The data is somehow finding its way from the inside to the outside at that point in time. That totally works, right? So this is a very common mechanism to actually be able to run backups from the outside of a container, simply attached to a database server, tell it to output all its information in some standardized format and save it to a file that is on the host machine and not inside the container anymore, right? So that's quite a common thing to do. So now perhaps you say, well, I'm not really excited about MongoDB because I never use it, which is why I decided to also show you a SQL Server example, okay? Anybody here SQL Server? Yeah? Probably. I thought so. So I've got this very simple example here, which is a bit of a .NET application that just goes and persists something. Actually, I think I've got this open here in Rider as well, so we can see, a bit of entity framework core. We're just going to create a product, one of these ubiquitous rubber chickens that everybody needs these days, right? Very important thing, rubber chicken. And it just attempts to save this in a database. There is a connection string down here somewhere. Use SQL Server, it says, just find a SQL Server running locally, okay? But I don't have a SQL Server running locally. I don't want one really. I'm on a Mac. Maybe on the other hand, on a development system, maybe you already have a SQL Server running locally. What do you do then, right? So with the help of a Docker container, we can actually bring up such a server any old time we need it. And we can even, if we want to, run multiple ones in parallel in different containers using different network ports or something like that without any trouble. So that's a lot easier and also more flexible than the more old-fashioned approach of running some kind of installer and waiting an hour, right? I like that. So let's see what we can do. If I'm going to run this now, this is going to take us 15 seconds of our lives, I think, but obviously it will not be able to actually connect to anything and it will give up after that. So meanwhile, in the other window here, we will go and run a SQL Server process. Now we already know minus RM and minus IT. And what we need now, though, Microsoft being Microsoft for a start, we need some environment variables. And one of them is called accept EULA, right? So that's what my Microsoft comment is about. Very important thing, of course, for them. We need to accept the EULA every time we do anything. So that is an environment variable, the parameter being minus E down here, okay? And we also want to map, actually these are not exactly in order what I'm doing, never mind. We need to map a port, that's 1433. Everybody knows port 1433, right? It's the one that all the hackers go for when they try to get into your data, right? Very cool. So that's like the SQL Server thing. And this port is opened by the process that runs in the container. Docker automatically generates a sort of virtual network thing for that, if I don't tell it otherwise, right? You can do all sorts of things, but by default, it generates a virtual network that is separate from your own network. So the port 1433 is used by the process in the container, and with this syntax we have right there, I'm mapping it to port 1433 on my local host machine. As long as we just want, you know, what I'm doing right now, just quickly run one instance of SQL Server, that is exactly right. On the other hand, I could run several and just use a different local port mapping, of course, right? So that's possible in the same way. Okay. What else do we need? We need to set a password, so that's another environment variable, MS SQL SA password. And I actually need to make sure, that's what I've got notes for here, to do this exactly the same way that I did inside my test application, because the SQL Server container is actually very picky. If you use a password for your SA password that does not adhere to password guidelines that Microsoft defines, then the container is just simply not going to start, right? We saw with Mongo that that's not a problem somehow, but, you know, Microsoft, right? What can we do? So password should be correct, hopefully. And what else do we need? Just as an example, I can also set a name here, like name SQL Server, right? That's a good name. Totally optional though, right? Just saying, because I mentioned it before. And then finally, what we need is the image name, just like before when I had like Hello World or Mongo. And for Microsoft SQL Server, the image name is mcr.microsoft.com/msql/server. And then follows something here. Well, not that, that's just shell completion. Follows something that I haven't talked about so far. And what follows after the colon is a tag. Now, the tag can basically be almost anything you want. Very often you find a tag that is just called latest, because that's like the latest version, presumably, right? But you can also use tags for versioning, and that's what Microsoft does. So we have a tag on the SQL Server that is called 2022, and then that has also got -latest on it. But this is completely up to the people who make those images, in this case, Microsoft, right? So you have to look up with them. Sometimes there are different tag versions where they use different underlying Linux versions. Sometimes they are different product versions. So there are actually SQL Server 2019 images available and that sort of thing, if you like. And there might be different sub-versions of that available. So in this case, I'm just going to go for latest. Now let's see if that works. It should just come up. Oh, okay, there it goes. It was waiting there for something for a moment. And, you know, it is just as verbose, of course, as the Mongo that we saw. Now, back in the other shell here, we can see the error that I did not exactly wait for that previously happened, right? It had an exception here because of the timeout, basically. I think this takes about 15 seconds. Oh, it ran for 17 seconds. That's creative. Okay, never mind, right? And if I run the same command again, now that SQL Server is available locally, it suddenly says, hey, we saved a product for this rubber chicken item. So that totally worked, right? So now I have a local SQL Server running, much the same as the Mongo one, and that's, like I said, that was how I began using Docker at some point, because I found that very valuable. If you work with different client projects, or you'd like to simply quickly give something a try, whatever, locally to test something out while you have things installed on your machine. These days, I don't usually install products like SQL Server or so on my machine anymore. It's just not necessary. I just spin them up when I need them, right? SQL Server installation process, I think, I don't know, how long does that take today? Who did it recently? Oh, yeah, you did? Well, how long? 15 minutes, okay. You had a fast machine, right? I remember when that took almost 2 hours, but times change. I'm glad to hear it. Yeah, nevertheless, 15 minutes. Of course, the images that I'm using for these demos are already on my machine right now, so that's important to say. If they were not on my machine, that's why I haven't said anything about it specifically, the exact same commands that I was using would still work, because Docker would just say, okay, I need to go to an image registry, and it knows all the ones that I'm using here automatically, and find this image that I don't have, and then it goes and downloads it, right? So the only thing is you have to wait for it. That might take a little while. Some of those images obviously are gigabytes in size, depending what it is. So that's a bit of time going by really, but nothing else. Okay, now a couple other things that we can do for running images before we get to the idea of also creating some for ourselves. I have, for example, an alias here configured in my system, which is called .NET 10, and it expands to a Docker command like this. Now, .NET 10 is currently in a preview state, right? I don't actually know what the current version number of the day is at the moment, doesn't matter. And I also do have it installed locally, to be fair, by now. But it is a great idea to use an image simply to be able to run an environment that you don't have installed locally, right? Because maybe you don't want to, and if you're afraid of breaking something else or whatever. With .NET on my machine, for some reason, that happens quite frequently when I try to have multiple major .NET versions with workloads and tools and stuff installed side by side. Suddenly I can't use my .NET command anymore. I have to reinstall everything. It has happened several times. I don't know if you're familiar with that problem. Anyway, by the by. Now, in this command here, we have two parameters that are kind of new. Here they are. So we've got this -v thing here, which is for volume. And it means that we are basically projecting, or the Unix terminology is mounting, a particular path into the running container. So the particular path is that, what happened here? Is this. I can't use my arrow thing here anymore. Oh, there we go. There it is. The little dot, right? That's my path, because that is the local directory that I'm mounting into the container. And inside the container, it will use this path /project, right? PRJ, whatever. Sometimes I call it source or something. It doesn't matter. It just means that the contents of the local folder that I'm currently in on the host machine will become available automatically inside the image, the container. And the -w here sets the working directory. So I'm also going to find myself in this particular path right away. So if I run this, we should see, let's do it. Here we go, that I can see the same contents. I'm zoomed in now, of this use-ef program, right? That is that I was just looking at on the outside of the container, but now I'm inside and I have a .NET 10 tool chain available. Actually, funny thing, if I do .NET version in here, it does show me that. Oh, that's fascinating. Maybe I'm in a different directory or something. Okay, I'm confused because I did have here a couple of. Oh, no, okay, I'm not confused anymore. Isn't that fantastic, when you feel that way? I was just remembering that I have a global JSON on this level of my repository right now because I was having some trouble with some of the Docker publish examples, .NET publish examples, I'll show you in a moment, when they were trying to use .NET 10, right? It's a preview, there are issues. So I brought that down to version 9 using this global JSON. And then now if I bring up my old version 10 command here again that I used a moment ago, and I do .NET --" version like this, then there is all of a sudden an error. And that's what I was expecting, but I had forgotten that I was in the subdirectory. So when I did it the first time, the inside of the container could actually not see the global JSON that is one level higher up, right? So that structure had me confused there for a moment. So the container can see the folder. It's actually a pretty good illustration, the folder that we actually mount. But the fact that there is something else higher up in the hierarchy that would also be considered by .NET normally, right? We know that, but it doesn't work in this case because the container can't see it. Right, so anyway, this happens. If, on the other hand, I just go to some entirely different place, I'm still inside the container, right? I could totally go to a different directory where there's no collision there, and suddenly my .NET command, of course, returns the version 10 correctly, as you would expect. Okay, so that's kind of cool, working with these environments, that's good fun. I've also got an alias here, just as a quick side note, that looks like this. So I'm sort of combining another few different commands with the same thing. So I'm killing all my old object and bin folders first, if there are any, and then I'm running a build here just by passing the .NET build command right at the end, so I can quickly apply this to some kind of a local folder, right? So there are a lot of things like that you can do. Okay. Now, oh yes, final example about running containers without creating them yourself. I have here a quick example for the project test containers. I don't know if you're familiar with that. It's kind of related to Docker because it uses Docker, but then again, you might never notice that if you don't really care. So for that reason, some people might be using test containers, I imagine, and never quite notice that they're actually based on the same technology we're talking about today. So in here, I've just got this simple class here, right, like this, that has test containers MS SQL thing here. And we create one of these MS SQL containers with MS SQL Builder, right? Stuff like that. So this is basically a library, new SQL connection that goes to the other container. This is a library that we can use in a testing setup. I think this is Microsoft Test, I think, MS Test that I'm using here, but doesn't matter, right? And this library enables you to spin up a container. In this case, again, I'm going for SQL Server, but I think they've got some 50 or so other types of infrastructure images that they can bind to directly. And then I'm running some code against this here, like a unit test, basically. And this executes with the running container. So let's get out of here and do .NET test. Oh, one thing before I start this, I've got this separate thing here. Oh, we've still got the SQL Server. Well, this is a command line tool that monitors Docker, right? It's called Lazy Docker. And it has now detected for me, because I totally forgot about that I've still got the SQL Server running on the other in the other window here. Let's quit that one. Now the list is empty. Actually, let's quit out of it and rerun it so it's all empty. And this allows me to quickly trace. I'm going to flip back and forth. Once I do .NET test, I thought oh, hang on, what's going on? I'm in the wrong thing here now suddenly. How strange. .NET test, here's my command. And where's my, all right, oh, here's my lazy Docker. Okay, sorry about that. So, .NET test. Once I run this, I'm going to flip to the other window so we can see what happens. There it goes. Flip here, and we'll see that the container pops up that is automatically started. And now it's started the SQL Server. You can see that run through. And after a few seconds, the process is over. Actually, I think it's over already. This one always hangs around another couple of seconds or so. Yeah, see? Build succeeded in 8 seconds. My container-based test has succeeded. And that's how easily you can use containers to run tests against whatever type infrastructure. And you can basically provide bootstrap data that it uses and all that kind of stuff for a database server, right? Like I said, they also have other types infrastructure available in this project that is all container-based and can be used the same way. So yeah, cool stuff, I thought. That was a quick demo really for something else you can utilize when you just run your own images. So, right. Now, for the purpose of actually creating images, that's my second part here, I thought I should mention quickly, hopefully, that .NET actually has built-in support to create Docker images, or generally container images these days. Some of you might have seen that. Microsoft has been pointing it out a couple of times at .NET Conf and whatever, but I don't know if it became a great big feature. Some people use it, I believe. It's very easy, so let's give it a try. I'm going to do .NET new console -o NDC 25 or something like that, and then go in there. That's the one, thank you. So .NET run, of course, is going to run that thing locally. Hello world, it says, lovely. Now, what we want to do is edit the project file here and put a couple of items in there that are necessary to make this particular project work with an image, with image publication, right? So I need to do is publishable, like that. Okay, thank you, Copilot. And we also need to do what's the name of that thing? Enable SDK container support, I think. Hey, okay, there we go. All right. So these two are required if you would like to use this mechanism I'll show you with a console application template, right? Microsoft being Microsoft, did I say that before? For other type project templates, for some reason, the mechanism is sometimes a bit different. So you're going to have to look that up, unfortunately. This is supported technically for all kinds of web API services and a variety of other template types, but the particular way that you make it work is not the same every time, right? Bit strange, but there it is. So let's save this, and then I can suddenly use the .NET publish command, right? You all know .NET publish, totally normal deployment thing, but we can use this. Let's make this quite verbose here, like this. And then we use a target that is suddenly available there, which is called publish, container, like so, and run. And it goes and builds a container, or an image really, which is a bit of a strange terminology that they apply there suddenly. It builds an image of my application, right? Fully automatically. This takes into account a lot of options that you might have or not have in your project file. Depending on your project's configuration, different build processes are used, and different base images are also used. So in this case, it decided to use a base image here called runtime, okay? There are several others. Microsoft has elaborate documentation. Again, I think there are probably about 12 or so at least different base images for various purposes. And they are usually auto-selected on the basis of the particular properties that you configure for your project. Of course, the Docker command itself has a lot of options, right? And Microsoft has gone to the effort of replicating many of these options in their own project file specification so that you can influence a lot of the same things by using .NET specific project options. So that's the idea there. Right, so if I do something like docker image ls pipe, grep NDC here, then we'll see this image. That's like a 319 megabyte image that has been created. This is a bit misleading, I should say, because basically in this image list that Docker outputs, you see it counts the size of the base images every time, right? Whereas the newly generated image really only occupies a small amount of data as much as the new image adds to the storage, basically. They use a layering mechanism, so your own new image might only use one extra layer, and there's only a small amount of data in there, maybe a few megabytes or so, but it will count all the megabytes of the underlying layers. And if I have 20 of those in the system, it'll count them 20 times, even though that's clearly quite untrue, right? So that's a little bit strange. So your image is not really entirely 319 MBs of size, but that's what Docker will show you here. Of course, we can also run it, like docker run -rm ndc 25, like so, and it says hello world, right? So that worked. Lovely. A couple of other things here. So for instance, let me show you this example quickly. We can build an alternative version of it by going -p, that's a project option. So we do publish trimmed equals true. That's an option you can use in a CS proj file as well, right? Not connected really to the whole thing. Container image tag, image tag equals trimmed. That is a special Docker publication option because it actually sets the tag to something other than latest, right? The previous one here was using latest. I didn't specifically mention that, but it did. So now we're going to use trimmed. And then finally, because I'm on a Mac ARM architecture, I need to tell it that the architecture of the target is supposed to be Linux ARM because it will perform ahead of time compilation, and it needs to know that for that reason. So now we have a completely different image here, different project options, and we have a different base image called runtime depths, this time the one that is selected. And if we bring up this list again here, where did it go? Here it is. Then this image only has 105 megabytes of data there. So it's a lot smaller than the one we previously generated because it's trimmed and all sorts. There are ways of making it smaller still. Microsoft is now including all the globalization functionality in the standard base images. There are ways of setting certain project options that means that that goes away, and then you save a lot of memory again for the image. But yeah, these are optimizations you can apply. They will always have a certain size, these .NET images. .NET is not the smallest deployment size in the world, right? So nothing changes that. Okay, yeah, so these are a couple of variants in here. Oh, I was going to quickly show you that the interesting thing with these images is if I'm going to run, oh, actually, I haven't even run the trimmed one yet. Hey, there it goes, right? That works too. And if I do latest again, and then I do something like bash behind it, like we've seen, then you'll notice that they actually configure these images in such a way that they totally ignore any values behind the command line. They are passed to your running application as arguments, right? That's important to know. So if you were to accept some arguments in your main method, then you would be able to see those arguments that are being passed there. But I can't overload them like this. And instead, what I would have to do in this case is to do -- entry point bash. And that totally doesn't work either, does it? Because I think I forgot the -it in there. Okay, there we go, right? So now I'm in, okay? Now, the other funny thing, though, is, and this is a bit of a trick that's coming up here. Now, if I do the same with trimmed, you will find that that doesn't work either, because one of the things that is actually trimmed from the trimmed images is stuff like bash, right? There is no bash. It's a security feature, right? If there is no shell, then the bad hacker that might make their way into your running container can't so easily do anything with your system because there is no shell environment. However, Docker has a cool command which is called docker debug, and we can use that one. It basically runs a sort of sidecar container. And I've already got this on my system, otherwise it would go and download it. So now we're in this sidecar container and we're looking into the other image that doesn't have a bash shell. Now I have a bash shell and I'm in this path here inside this image, and I can look at it, and here's my compiled .NET application and all that kind of fun, right? I can even start it. They do this so cleverly that all the paths work and everything, so that's really nicely done, right? Nice little trick on the side, I think. Docker debug is not familiar to lots of people, I believe. Okay, now how much time do we have? 18 minutes. I've still got a lot of things to show you. Well, a few at least. Okay, so in order to build new Docker images, people sometimes use slightly strange approaches, right? For example, let me show you this here. I've just got an ordinary Rider project here. So this is the one that I was using here, the NDC 25 project. Now, if I'm going to add here a Docker file to this project, let's just go and do that, then you end up with this kind of thing. And you might have seen that before because that's a standard template, right? This is not specific to Rider or JetBrains or anything. Same thing is going to happen if you create a Docker file from the command line in your .NET Core project or whatever. So this thing is a case of where Microsoft came and said, hey, we like this Dockerfile thing. We're going to use that. We'll do it all completely differently, okay? So what they used is the multi-stage build process that is supported by Dockerfiles. You can see this because we have multiple blocks, and they each begin with this from statement. So we do something by way of using this runtime image, and then we do another thing here by way of using the SDK image. And then suddenly, down here, we actually use the build alias that was generated up there to do another step on the basis of that, right? And so on. So that's all really cool. It'll take you a long time to understand all that and find your way through for complicated build systems, right? That's what that's for. Microsoft is using it for a totally different purpose, which is that in Visual Studio, they have some built-in magic mechanism that says, if we're running in the debugger, for example, then we will actually look at this Docker file and only execute the first, I think, 2 or 3 stages of it. Okay, that's what they do. They just randomly define that for themselves because it allows them basically to build an image that is sort of like a partial image up to the build step, but not the actual deploy step, right? So this one here, where it publishes this one, and then the last one here where it actually copies the build artifact into the final path and so on. So these steps are then randomly skipped by Visual Studio. Well, not randomly, of course, there's a plan, right? I'm just saying from the perspective of a Docker file, it's a random idea to say, we're just going to stop after 2 of them, right? For example, that's our idea of handling this. That's what they did, though, and that is why the standard Docker file that they generate always kind of looks this way. Now, if I was going to build an image on this basis, we can totally do that. Now I'm using the Docker command to build. So this goes Docker build, and we're going to assign a tag to it. So this will be NDC 25 manual build 1, right? And it needs the local directory, and it's going to find everything in there automatically and perform its build. Outputs a lot of things as well. And the end result of that is, let me find my last command here, there we go. The end result of that is that this new image that I just now built 7 seconds ago is exactly the same size, and it's also very similar internally, just to be clear, to the one that we built first, which is called latest, right? So that's basically the same thing, more or less, that they do there. Now, when I use Docker for local development, I don't usually use this kind of approach, to be fair. I just don't. It's not a useful approach in my eyes. What I do instead is something different. I'm going to rename this here and say this will be Dockerfile MS, Microsoft version, and we're just going to do a new one. And then we'll just start in there and say, from, so that's always where we begin with some sort of a base image, and that'll be microsoft.com/.NET SDK, right? We want to develop things, we use SDKs, and we do workdir/source, and we do copy, and copy everything from the local directory in there, and then we do .NET run, like that. And that's a good Docker file, right? I can read every bit of that. It's very simple, and it actually totally does its job. It's not quite perfect yet. We'll get there in a moment. But if I'm going to build this, that'll be my manual build number 2. Then, of course, one of the things we find is that it seems to be ginormously large, right? But that's, of course, because 1.24 gig or something like that is already the size of the standard SDK image. And that is, as I said, counted a second time against my image. Now, if I do this 10 more times, it looks like I've consumed, what is that, like 12 gigs of memory or something, but I haven't really. It's only there once, right? That's a bit of a lie by the Docker system. Anyway, so really large image. If I run this, it'll also kind of take a short while longer. Where did we have it last? Run. Okay, let's do this. So that will be manual test 2. No, manual build 2, not a test this time. So here we go. It takes just a second longer on startup because it actually builds my application first, right? But the advantage of that is that I can actually do inside that image whatever I want. So I can do .NET watch run, for example. And let's build this one more time and go for number 3. and then we do .NET run manual build 3, and insert one of these volume mounting things here. So we were copying stuff into the source folder. So now I'm also mounting stuff into the source folder. And that means that the current version of the files I'm working with in my local file system are now available to the running process inside the container. So now here it says hello world. And if I go back to Rider and just go and change this and say hello NDC, then switch back, it is rebuilding right there and going hello NDC, right? Yes, we can do that locally too. Well, that's exactly my point, right? We can do that in a container too. And the container, of course, does not have to have the same environment that you're running locally, right? So this can totally watch whatever is going on. Hang on. Right. So we've seen these build processes. We have about 11 minutes. Yes, I can show you the coolest stuff. So what remains sort of to kind of bring everything full circle to where I started. And I said, look, you know, we have maybe some infrastructure like SQL Server or Mongo or whatever. So now we can also build systems that automatically run all the components we need in order to run our application system, even if that's like many processes, right? We're not going to do many processes, but we'll do one, plus the infrastructure we need, the SQL Server. So in my project here for the, I think it was called Use EF, okay? Let's just quickly quit this one. There we go. Use EF here. There is already a Docker file in here that kind of looks exactly like the one I just showed you. So I pre-created that secretly, right? Sneakily almost. And now I'm going to add another configuration file in here. And this file is called a Docker Compose file. Docker Compose, the file itself is called compose.yaml these days. Sometimes it used to be called docker-compose.yaml. If you see that somewhere, same thing, okay? They renamed that a little while ago. Now in here, we can now reference a variety of separate services. That's what they call it generally. Any individual running container is called a service in here. And one of them is already there, and it says, if the use EF image doesn't exist yet, then we're just going to build it by using the Docker file that is in the local project. So that's what I was doing just before with my other project, right? Only now it would happen automatically. And then I can also go and add things in here. So I'm going to do SQL, and the image for it is, again, this weird and wonderful Microsoft thing, mcr.microsoft.com, MS SQL Server 2022 latest. That's what we were using, right? And I can do environment, like so, and put my MS SQL SA password in there. That, again, I must get right, otherwise we have login errors like that. And we'll do accept EULA 1, like so, right? So that's the same service that we previously ran manually, but now it's part of my config file. And what I can do now is, like, the real magic is the fact that I can connect the two. So up on this one, I'm going to go depends on and refer to the other one. What that does is it makes the service that is listed under SQL available inside the container for the use EF application by the name SQL, right? Just like that. And so I'm going to go to my program CS and use this other variant of the connection string down here, which uses data source SQL as opposed to data source 127 and so on that was there before, right? The rest of it is the same, but this one now attempts to use the DNS name SQL, and that automatically resolves to the other running container. I mean, assuming we run it, which I haven't done yet, so let's go and do that. We do, oh, I'm in the wrong folder now. This would be use EF, like this. And we do Docker Compose app, and I do -- build, which is technically not always required. It just makes sure that we're building the current version, right? Since I do this demo on my machine occasionally, I'm better off making sure that I actually build this right now. So let's do that. It quickly builds everything, and it runs SQL Server. And then at the end of it, more or less, I think, it should also be running the .NET application. Nothing happening at the moment, that's concerning. Sometimes it takes a second or three. Is it done already or what? I'm a bit confused. I don't know if it's already done. Sometimes it happens out of sequence. That is definitely possible. Let's see in the other window here if we have. Yes, we have both of them running already, plus somehow another one that I forgot about in between, apparently. Okay, that's all good. Process is running. Oh, look at that. It was, in fact, still doing something. That could have been related to the network connection, to be fair, because it did a .NET restore initially, right? And that might run very quickly a few times, and then the next time it might not have immediate contact to some online thing to do its checking and whatever. Maybe that's why it just took a while longer there. And it says product saved right here. Okay, so that's lovely. Now, I've got those two processes running just using the one configuration right there. And I'll also show you how to basically do the same thing we did before, where we combined them and we were able to also, let me tear this down, to also develop the code at the same time. In Docker Compose, we can add this configuration block in here. Hang on, like that. That is called develop. And there is a watch block, and we can make it watch things. This is actually a lot more elaborate and with lots more flexibility built in. Oops, that was not intentional. There we go. But the idea is the same. We're basically watching the local directory, and if anything changes there, we will make sure that the source folder inside the container is updated, synced, right, based on this little mode specifier there. And because we have .NET Watch running inside the container already, it should then rebuild the application. So let's give that a quick try and do up and build again and rerun this entire thing. There we go. Is it going to take so long again this time? I don't know. I was testing it a few times earlier and it ran more quickly than it does now. That's a bit boring. We do have a couple of runs coming up still. I noticed that I'm actually, oh, there it goes now. All right, okay. So Rubber Chicken was running, so let's make a quick change to that here. And go, changed, save. And in the background, it should recognize that did I save this? I thought I did. It's not reacting, is it? That's totally my fault. I was going to point out to you that down here at the bottom of the window, you can see this thing called Enable Watch right there. Guess what you need to do with that in order to actually make watches work, right? Well, you have to execute it, unfortunately. So let's do that. Hit the W button. There's also the possibility of passing -W for watch to the command line right away. I did not do either of these things. So then, of course, it didn't work. So we're going to do change again, save. And this time it reacts and actually builds the thing. Lovely, okay? So now the last thing I want to show you, and that's hopefully going to be possible in the remaining few minutes that we have, is that this entire development that is now already looking reasonably convenient, I think, can get even better because we can even debug stuff that runs in containers. The mechanism to do this exactly depends a little bit on the tool you use. So in VS Code, for example, you should probably consider dev containers, which I have a quick slide about at the end. Really, we don't have enough time to look into that. I'm using Rider, and it doesn't need dev containers in there. It uses a built-in process, so that might vary a little depending what tools you use. But it's possible everywhere, basically. Let me quickly put a bit of code in here. Hello, while true, right? We're just going to keep doing something here indefinitely, like this, so that we can actually see, oh, hang on, I need like a thread.sleep or something in there. So we create one of these data records every 5 seconds, so we can see that, working away, basically. And then build this one more time and run it. And now, of course, we expect that to start running and creating these records. I hope this is going to catch up with us in a second. Meanwhile, in Rider itself, I can now go, let me jump out of this mode here. I can now go to the Run menu and say Attach to Process. Typical sort of debugger thing, right? And we can then attach to Docker right there and find the Docker that we're using, the particular image, the particular container, of course, in the list. And Rider has the ability to install a couple of remote execution tools into the image. That's where this differs, right? There isn't really some sort of a standard mechanism, but this is the way that they do it. Now I noticed that the use EF one apparently is still not with us somehow. Is that possible? Yes, that is possible. I wonder why this does take quite so enormously long. Can that really be a network thing? Well, I was just realizing when I did it last time that I'm in a VPN here, so maybe if I kill that, let's give that one more quick try here. I hope that we can see this final example working quickly. I did that earlier several times and it came up quickly every time, so I'm confused. Maybe the Wi-Fi has lost its edge here somehow. Yeah, well, we might be running into technical trouble in the last couple of minutes of the talk here, apparently. I'm not really sure what I should do exactly to help resolve this. I suspect that it probably has something to do with some sort of online access that is not coming back to us as quickly as it should. So now we're waiting at the same spot again. I should probably modify this somehow so that we don't check anything online at this particular point here, but yeah. Well, I hope that in another minute or so we'll be able to see this happening. Oh, here we go. Oh, that was lucky. Okay. So, lovely. It should be able to talk to the database, presumably. Oh, yes, here we go. Okay, that was just in time. It says we have now got this rubber chicken and it saves the new one every 5 seconds. And the cool thing that I was just going to quickly show you is this, that if I'm going to go to Docker here again and reload this, there we go, that's my container. This process here goes pretty quickly. It also downloads some stuff online, but that's already on my machine. And here's now my container with the useEF process in it. And I can attach to this and simply run the debugger against this. The first thing that you see is that the running Rider instance actually shows me my console output from the separately running process inside the container, which is kind of cool, right? I think it's like remote work, basically, right? And then we can also go and like put a breakpoint here somewhere, and it stops, and we can see the variables that are available in the context. So the product, for example, that we create right there with those rubber chicken details in it and everything, right? So yeah, that's really nice. And in this way, I personally work with environments that are contained inside containers all the time. I've just got a few more words to say here about development containers. I was mentioning that. I knew that we were never going to have enough time to actually look into that as well, so it's separate. It's the idea that you create a specification file, which is this devcontainer.json thing up there, that tells you what a development environment looks like. Cool thing, right? So you can totally check that into source control and share it with other people. And it says, we need, this SDK and those tools, and we also need like whatever, a bit of Python on the side to do something interesting with or whatever. And then you can use this tool chain from the development containers to spin up a container like that automatically. And this also integrates with environments like VS Code or Rider and so on, so it can happen fully automatically from that. So that's very cool. It uses containers. It basically uses a similar sort of remote development tool set that we just saw with this debugger that went into the running container. This is kind of similar, right? It uses a similar approach to work with the processes in the container. So cool stuff. Check that out. The rest of my slide deck here has a list of commands that I showed you. You don't have to take photos of those. I have here the QR code in the top right that gets you the entire slide deck. So check that out. There are some links to other things I mentioned in between. And that's me. I'm all done. I'll leave that up for you to photograph right there. Thank you very much for being here. I appreciate it. Cheers.